So just real quick to refresh your memory, the Hamilton method, we first calculate the standard divisor by taking the population and dividing by the number of things we're distributing. And then we take that value and we divide it into each group so that we know exactly how many they should get. That's called the standard quota. All this is on the previous section's work. And then the Hamilton method rounds down and redistributes. The reason we're just focusing on this is because it's the easiest method to deal with. All of the methods have some sort of paradoxes and contradictions that you find yourself in. We're going to look at this through the lens of the Hamilton method. So we're just going to do two of the paradoxes that ended up happening, and things had to be adjusted as a response to these things. The first one was called the Alabama paradox. So this must have happened to Alabama back in the day. So it says the Alabama paradox occurs when a increase in the total number of items to be apportioned results in a loss of an item for a group. The reason this is a paradox is if you are distributing more things, you would think that everybody at least stays the same. But the Alabama paradox is by adding in more representatives, a state actually lost one of theirs. Okay, so this was a problem with the method. So what we're going to do, this is my example right here of the Alabama paradox, and then I have two for you. Again, just to keep the numbers small, we're just going to consider a small made-up country with 18,000 people and 3 states, as you can see in the table below. We are going to distribute 150 legislative seats among the 3 states. What we're going to do is I'm going to show you that the Alabama paradox occurs if we raise it to 151. Okay, so this example is intended to show you what the Alabama paradox is. So here's what I'm going to do. I'm just going to draw a little bar here down the middle. On one side of this, I'm going to do the Hamilton method with the 150 seats that we have. On the other side, I'm going to increase it to 151, and we're going to see what the outcome is. So here goes. So with the 150 seats, that's what we're going to do first, the standard divisor. Remember, that's the first thing that we calculate. How am I going to calculate that standard divisor?
Divide 18,000 by 150.
Okay, you're exactly right. We're going to divide the 18,000 by 150. And when I throw that down into my calculator, that turns out to be 120. So what that means is there's 120 people for each representative. So now what we're going to do is go through each state, and so there's A, B, and C. We're going to go through each state, and we're going to determine exactly how many representatives they get. So I'm going to take the 888 divided by 120, and that is 7.4. The 8,076 divided by the 120, and you get 67.3. And then last but not least, the 9,036 divided by the 120, and you get 75.3. Hamilton said, go ahead and truncate those. So 7, 67, 75. That adds up to 149. So that means I have one more representative to distribute. And which state gets that one more representative? A, yes. So we're going to increase A because it has the biggest decimal part. So it becomes 8 and 67 and 75. That is my 150. So here's what I want you to do, and I'm going to give you like a 90-second head start just because I don't want your forehead to crash into the desk from boredom. I want you to do the same thing with the same Hamilton algorithm, but this time, instead of 150, our number of things we're apportioning is 151. So give it a try, same process, and then we're going to compare the results. All right, so I calculated the standard divisor. Standard divisor is calculated by taking your total population, 18,000, divided by the number of things that you are distributing, in this case, 151, and that was 119.2. So then I took the 119.2 and I divided it into each of the states. So the 888 divided by 119.2 gave 7.45. The 8,076 divided by the 119.2 gave 67.75. And the 9,036 divided by 119.2 gave 75.81. So Hamilton says truncate. Once again, that right there turns out to be 149, right? Am I right on that? This time, though, I have two extra things to toss out there because we're apportioning 151. So this time, though, because of the changes, notice A doesn't get the extra one this time. B and C have the bigger decimal parts. So B goes to 68, C goes to 76, and A stays at 7. And so notice what happened. Okay. We increased the representation from 150 to 151. And then the way the numbers worked out is instead of state A getting 8, state A goes down to 7. So it lost a representative even though there were more total representatives. And mathematically, what's going on here is the situation that's susceptible to this doesn't always happen, but the situation that's susceptible to this is when you have, notice we have a group that is significantly less than the others by a factor of 10, right? State A only has 888. Everyone else is in the 8,000, 9,000 range. So that change of 0.8 in my standard divisor made it made more difference. That was more significant to state A than the others, and that's why the mathematics worked out that way. So that's the situation that happened, and that happened with the state Alabama. So, all right, that's why it's named that. So I'm going to have you do 2 of these. So exercise 1, I'm going to give you 3 or 4 minutes. It says a large company with offices in different buildings must distribute 148 new color printers to the offices. Okay, so so there we go. The printers will be apportioned based on the number of employees given in the table below. Does the Alabama paradox occur if the number of printers is increased to 149? So again, you have to do the problem twice. You have to do the Hamilton method for 148 printers. And then you got to go back and do the Hamilton method for 149 printers to determine does somebody get cheated a printer when they buy more? I'm going to get started on the work. You keep working. I'm not going to distract you, or I'm going to try not to distract you. And then we'll compare notes at the end and we'll talk about it. Okay, so here's what I've got. On the left side, I found my standard divisor by taking the 2664. That's the total, that is the total number of offices divided by the 148. And that gives me a standard divisor of 18. I then divided the 18 into each of these four numbers and got the following results right here that you can read on the page, 42.06, etc. Now the Hamilton method says truncate, so that's 42, 16, 35, 54. Up till now, does anyone have any different numbers than me that we need to talk about and see who's got it right, who's got it wrong? Okay. And so 42 and 16, 35, 54, what does that add up to?
147.
147. Everybody good with that? So I have one more printer I have to apportion, and that one more printer is going to go to office B because they have the highest decimal that was left off. So we've got A is going to get 42, B is going to get 17 now, C stays at 35, D is at 54, and then that's 9, that's 16, that's 18, yes, and then we carry the 1, and that's 5, 6, 9, that's 148. Great job. So there's the apportionment. And so now we are determining, does the Alabama paradox happen? If I buy one more printer and I add that to the apportionment, does anyone lose what they have? Well, let's see. So over here, the standard divisor, 2664 divided by 149 turns out to be 17.9. Divide that into each of those and you get these numbers here. So that becomes 42 and 16 and 35 and 54. So once again, that's 147. But this time we have two extras because we have 149 printers. So let's see. Well, this time those printers are going to go to C and D because they have the highest number of the decimal. So A this time is going to stay at 42 and B stays at 16. C is going to go to 36. D is going to go to 55. And there's my 149. Did the Alabama paradox happen? Yes, yes, the Alabama paradox happened. Okay, great. All right, next page. One more of these, and then we'll each just have one of the final thing. So exercise 2 up at the top. I want you to do the same thing one more time. I'll give you a little bit of a head start, then I'll get working. So you have 200 seats you're going to apportion, and then you're going to see, does the Alabama paradox happen if I increase that to 201? All right, so just going through the numbers here. Standard divisor, when there was 200 legislators was 5,000. Divide that 5,000 into each of the state totals to come up with these numbers right here. And so then the Hamilton algorithm says that becomes 49. This is 96. That's 54. Those three numbers there, 49, 96, and 54, what do they add up to? What was that? 199. Thank you very much. So I have to add one more, and that one more gets added to state A because it has the largest decimal. So state A becomes 50, B is 96, C is 54, and that is my 200 legislators, and boom, there's my apportionment. When I increase the number of representatives to 201, my standard divisor becomes 4975.1. Divide the 49.75.1 into each of these three states, and we get the following decimals here. The Hamilton method said I'm going to make this 49, 96, and 54 again, which again is 199. But this time I have 2 to add. And who do I add the 2 to? A and B. So A becomes 50, B becomes 97, and C becomes 54. It stays 54 rather for 201. Did this time the Alabama paradox happen? Did the state that gained before lose this time? No. A stays at 50. So this is not the Alabama paradox. So there it is. Okay, so there's a bunch of other mathematically interesting things, but just for time's sake, I just decided to pick one other. So the last one is called the new state paradox. I've got one example, you've got one example, so you're still gonna get out a little early today, so sorry about that. I know you want to stay here the full time. So the new state paradox says this, and you can see how this developed. You know, as a country, we added new states, and so there was things that had to be ironed out. So the new state paradox says that it occurs with the addition of a new group. Okay. So the new state paradox occurs when the addition of a new group and additional items to be apportioned decreases the previous apportion of another group. So you add a new state, you add the appropriate number of representatives to hopefully cover that state, but then when you go through the apportionment process, you see that it actually decreased some states' representation. So my example here is this. I've got a public library system that has received a grant to purchase 100 laptops and distribute it between its 2 libraries based on the population served. Determine the apportionment using Hamilton's method. Okay, great. So my standard divisor is 10,000 divided by the 100 laptops. And so that turns out to be 100. 100 people per laptop is what we're going to do. Can do this part without the calculator. So that means my quota for library A is going to be 21.45, and my quota for library B is going to be 78.55. I truncate, and that turns out to be 99 laptops. So I have to add one more, and so that means that library B is going to get that one more. So we have 21 and 79, that's 100 laptops. I know I went kind of fast through that, so I'll give you a second to get caught up. It's just Hamilton's method. We've done it now 19 times now. So if you're struggling with Hamilton's method, please let me know. Okay, don't leave here confused about Hamilton's method. So now we have this situation described below. A donor comes forward and says that they want to donate money to purchase 6 more laptops, provided that it serves an auxiliary center that has a population of 625. Okay, so determine the apportionment and if the new state paradox. So what we're going to determine is if by adding this new group, does one of these 2 here that we've already apportioned lose anything? So here we go. So my standard divisor this time Now I've added in 625 new people, so my population is 10,625. I've added in 6 more laptops, so my things to be apportioned is 106. So 10,625 divided by 106 becomes 100.23. We'll just go 100.2. So now I still have library A, I still have library B. I'm going to call C the center. C is going to be center. So now we'll figure out the apportionment this way. So library A still has 2,145 people it serves, divided by the 100.2 takes it to 21.41. Library B still has 7855 divided by the 100.2. That takes it to 78.39. And last but not least, center C has 625 divided by the 100.2. That turns out to be 6.24. So using the Hamilton method, I truncate. That turns out to be what, 99? That's 105. We still have one laptop that we need to apportion. That one laptop is now going to go to library A because it has the largest remainder. So library A becomes 22, library B 78, library C 6. That should end up being 106 laptops. And notice what happened. Does the new state paradox happen? Yes, because state A or library A went from getting, state B. State B or library B went from having 79 laptops down to 78. They got cheated one because of the new one. So the new state paradox happens because of that. All right, your last problem for the day and for the semester is on the last page. You're going to determine, does the new state paradox happen in this situation? You've got a country with three states, and then we're going to add a fourth state. Yeah.
So suppose a fourth state is that as shown in the table below. What's the population on the table below?
It's a great, I did not add the table below, did I? No, I did not. It is not there. Let me see if I can access it. All right, so go ahead and do the Hamilton for what you can see. So clearly I made another mistake, but that's okay. You're used to that now. I'd have to run to my office because the picture's not on my cloud. So I'll be right back. All right, when you go to do the second part of this, as you can see, I left off the most important part, which was the table. So the A, B, and C of the table are the same. What you're going to do is you're going to add on a state D that's going to have a population of 78,000, and that makes the new total population 978,000. The populations of the other three states stay identical. Okay, so just for time's sake, sorry about that. Sorry about the drawing there. So at the top, the standard divisor was the population 900,000 divided by 60. So that divisor is 15,000. You divided 15,000 to each of the numbers. And when I truncate, I got 4, 15, and 40. That's 59. And I added the extra 1 to state C because state C had decimal 0.44. So here's the apportionment, 4, 15, 41. Then when I added that extra state with 78,000 people and 5 additional seats, we had 978,000 divided by 65 seats for 15,046. Divided the 15,046 into each, and when I truncated, I got 4, 15, 45 for 64. Needed to add one more. This time, when I add the one more, it gets added to state B because it had the highest decimal. And notice, did the new state paradox happen? And the answer is yes. State C decreased its representation, so that is the new state paradox. I'll leave this on the overhead if you're still copying. If you're